Now we want to consider questions on chemical equilibrium right now, and you might need to go and read other questions surrounding it. Like I always emphasize that you need to get the concept behind it. Once you've understood the concept, it will be easier for you to answer any other questions related to that topic. Now look at this chemical equilibrium. One of the aspects we must
I will blow your mind.
One of the aspects we must read is the Chatelier's principle. And what is the Chatelier's principle? That Chatelier principle states that when a system is in equilibrium, and one of the factors that affect the position of equilibrium is altered, it makes the equilibrium to shift. Now, one of the factors that affect the position of equilibrium, we have temperature. We have change in temperature, we have change in pressure, we have change in concentration. Those three things are very important. They are major factors that affect a chemical system in equilibrium. Imagine I'm holding this marker. See the way I'm holding this marker. So this marker is balanced. That's why it's standing. So if I just do something like this, you see that the marker is shaking. The reason why the marker is shaking is that there is a particular thing that happened on it, and the marker will try to shake so that it will gain balance. And that was what the Chatelier's principle is trying to explain. Now let's consider this equation. The question says consider the equation below, blah blah blah, x, and everything is in gaseous system. This G means that x is gas, is a gas, y is a gas, and then the compound formed, the product formed is also a gas. Okay, then we have the delta H. The delta H here, which means that change in heat. And when we talk about change in heat, we mean when you subtract the final from the initial. So it's going to give you this minus 52. Now, this delta H is very, very important. It's very, very important. And that one is talking about whether a reaction is exothermic or a reaction is endothermic. For an exothermic reaction, the delta H, this delta H is always positive. So it means that it's exo. For an exothermic reaction, the delta H is negative, which means that heat is given out. And when we say heat is given out, it means that at the product, it will be there at the product. I repeat, exothermic reaction is a reaction in which heat is given out. So at the product, it will be at the product side. So whereby endo is absorption of heat. So at the reactant, it will be added. So the way we are seeing this equation now, this 1 year question, we do not write it anyway, but by implication, because of this delta H is negative, this equation is telling us that heat is given out. And when heat is given out, it means that heat is added to. So deliberately I will add heat to this place now to show that reaction is an exothermic reaction. Okay? The question is now asking us that state what happens to the yield of SY2 when the temperature is increased. For you to know what will happen, you must firstly determine whether that reaction is exo or endo. Now, if this reaction is exo, at equilibrium you've already had heat here. Are you with me? If you increase the heat, where do you think heat will fall to? Heat will come here, because heat is already here. So when you increase the heat of this system, heat will not come here again, because we are talking about system in equilibrium. So heat is already at the product side. When you are increasing the heat now, since heat is already here, heat will not come and stay here again. Heat will rather come and stay here. And by implication, it means that it is this backward reaction. This arrow is showing that this reaction is backward, while this arrow is showing that this reaction is forward. So when we increase the heat it will favor the backward reaction. And what we are saying that if backward reaction is being favored, the equilibrium will shift from, this is my left and this is my right. The equilibrium is shifting from right to what? To left. If we are to increase the temperature of this system, because it will not come to this product side again, it will rather come to this reactant side. So if we are increasing the temperature of this system now, the equilibrium position will shift from where? From right to left. Where will it favor? It will favor the backward reaction. It will favor the backward reaction. But the question is actually what happens if the temperature is what? Is increased. So it means that there will be decrease. There will be decrease in the heat because it is this place that will be favored. This place will be decomposing to produce this. So increase in temperature of this system will do what? Decrease. It will lead to the decrease in what? In the heat. In the heat of what? Of SY2. That's what we have. There will be decrease in the heat here because the backward reaction will be favored instead of the forward reaction being favored. Just because this reaction is an exothermic reaction. So let's move on to the question number 2. Explain the effect of decrease in pressure on the equilibrium system. Now take note of this. Pressure will have effect on the system for 2 different conditions. Number 1 conditions that can make pressure to have effect on the chemical system is that the number of moles, the number that we use to balance this equation must be different. By the time the number of moles of the reactant and the number of moles of the product must not be equal, there must be difference in number of moles. That's one of the reasons why pressure will have effect on that system. Another reason why pressure will have effect on a chemical system is when that system is a gaseous system. When I say gaseous system, I mean in the equation gas is present. If gas is not present, if that equation involves solid particles, pressure will not have any effect. So in this case now, let's take the differences in number of moles. Here we can just say the number of moles here is 1, the number of moles here is 2. So 2 plus 1, we have 3 moles here, and then we have 1 mole here. Automatically we have difference in the number of moles. So now the question now is not that explain the effect of decrease in pressure. If you are decreasing pressure, which side will you decrease? Is it the place that have higher number or the place that have lower number? Which one? Answer. You want it to be balanced. You want it to be at equilibrium. Which place are you going to decrease? Automatically you are going to decrease the place that is having higher number of moles. If you are to increase this pressure now, you are going to increase the place that is having lower number of moles. So here now, if you have to explain the effect of decrease in pressure, if you are decreasing the pressure, it is the backward reaction that will favor it, because backward reaction is having higher number of moles. So decrease in pressure will make the equilibrium position to shift from which place? From right to left, favoring the backward reaction. Or you can also see decreasing in pressure here will also lead to the decrease in the heat of XY2. Decrease in pressure will lead to the decrease in the what? In the production of XY2, because decrease in pressure will favor the backward reaction. It is only increased pressure that can favor this place, just because this one is 3 and this one is 1. The last question there, state the effect of catalyst on the position of 1 equilibrium. Catalyst does not have effect on the position of a system in equilibrium. Catalyst does not have effect on the system in equilibrium. What catalyst does is that it alters the rate of chemical reaction. Catalyst can speed up and catalyst can slow down. Do you get it now? So catalyst does not have effect on the system. And what's the effect of catalyst on activation energy? Exactly that's what catalyst does. A positive catalyst will lower the activation energy so that the reacting time will be attained faster. A positive catalyst does what? Will lower the activation energy so that the reaction will occur at a very fast rate. So this is the convenient point. I'll be dropping the curtain of this tutorial today. Do well to subscribe. If you have not subscribed, kindly subscribe, share these videos, like these videos. If you have any question, drop the question in the comment box, and I'm very sure I will definitely get back to you via the same channel. Thank you for watching. God bless you. See you same time next week. Bye.